Hello, viewers. Welcome to another episode of Knowledge Sharing. For today, we are going to look at this topic, Grade 9 Mathematics. So, in this episode, we are going to look at all of Grade 9 Mathematics in 60 minutes. So, here we are going to treat Part 1, starting from Part 1. Under Part 1, we have algebra. Under algebra, we have polynomials, and also we have equations. So, the next step that we are going to look is the exponent laws. So, on these laws, we are going to see these numbers of rules. So we are going to use the subsequent example. So number one, we have product of power rule. In product of power rule, when we have x to the power of a times x to the power of b, simply means that x to the power of a plus b. For example, if we have 5 to the power of 3 times 5 to the power of 2, simply means that we can, since we have the same base, we can have 5 to the power of 3 plus 2, which is equals to 5 to the power of 5. So that is the answer. So in this second one, we have quotient of power rule. So we have x to the power of a divided by x to the power of b. Simply means that we will have x to the power of a minus b. We have, for example, we have 2 to the power of 4. Then we have divided by 2 to the power of 2. Simply means that we will have 2 to the power of 4 minus 2, which is equals to 2 to the power of 2. And we all know that 2 to the power of 2 equals to 4. So this will be the answer. This is the rule that we use for us to find the solution of this expression. So the third one, power of a power rule. When we have x to the power of a all to the power of b, simply means that x to the power of a times b. We can interchange the power, either a or b. But if we have a situation, let's say, for example, we have 2 to the power of 3 all to the power of 2. This is the same thing as 2 to the power of 3 times 2, which is equals to 2 to the power of 6. So here, in the third one, we have power of a quotient, where we have a all over b all to the power of x. It's the same thing as a to the power of x all over b to the power of b. Same thing when we have, let's say, for example, 2 all over 3 all to the power of 2 is same thing as 2 to the power of 2 all over 3 to the power of 2. So doing, we have, this will be 4 all over 9. So this is the answer to this expression. So the next one is number 5, power of a product. We have a times b all to the power of x is same thing as a to the power of x times b to the power of x. We can distribute the power into each of these variables. Example, when we have 2 times 3 all to the power of 2 is same thing as 2 to the power of 2 times 3 to the power of 2. This is same thing as 4 times 9, which is equals to 36. So this is the answer to this expression. So the next one is zero exponent rule. When we have x to the power of 0 equals to 1. We all know that anything raised to the power of 0 equals to 1. Example, if you have 100 raised to the power of 0 equals to 1. If you have 1000 raised to the power of 0 is equals to 1. So anything raised to the power of 0 equals to 1. So the seventh one is negative exponent rule, where we have x to the power of minus a, the same thing as 1 all over x to the power of a. So in this case, when we have 3 to the power of minus 2, the same thing as 1 all over 3 to the power of 2, which is equals to 1 all over 9. So this is what we have, and is the answer of this expression. So the next one we are going to take is exponents laws example. So number 1, we have 4 to the power of 3 times 4 to the power of 5 divided by 4 to the power of 2. So from here, how we are going to solve this is for us to take 4 to the power of 3, since we need to apply the rules that we said before. 4 to the power of 3, this will be 4 to the power of 3 plus 5. Then we have divided by 4 to the power of 2. We all know that this is the same thing as 4 to the power of 3 plus 5 is 4 to the power of 8. Then we have divided by 4 to the power of 2. Applying the rule, we will express that as 4 to the power of 8 minus 2, because we have division sign here, minus 2. This will give us 4 to the power of 6. 8 minus 2 is 6. So when we evaluate this, it's going to give us 4096. So this is what we have from this expression. So the next one is number 2, where we have minus 2 all over 3 to the power of 2 all to the power of 3. We know that in the roots of this exponent, 2 we multiply by 3. So this will become minus 2 all over 3. Then we have all to the power of 2 times 3. So this is the same thing as minus 2 all over 3 all to the power of 6. So we have another expression here. So here we can write it this way. This can be given as minus 2 all to the power of 6 all over 3 all to the power of 6. We can separate this. So this is the same thing as having minus 2 times 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 minus 2. We have 1, 2, 3, 4, 5, 6. So we can see that this will cancel here, and this will cancel here, and this will cancel here. So we don't have minus again. All over, we have 3 to the power of 6. Why we did this? For us to see how many times the negative sign will cancel each other. So in this case, the numerator will become positive. So this will become 64 all over 3 to the power of 6 is same thing as 729. So this is what we have from this expression. So the next one we have number 3, 5 to the power of 4 times 5 to the power of minus 7. So this is the same thing as applying the rule. We have 5 to the power of 4. When we add this will become plus into minus 7. So when we expand this, we have 5 to the power of 4 minus 7. So in this case, 4 minus 7 is same thing as 5 to the power of minus 3. In that rule, we know that 5 to the power of minus 3 can be written as 1 all over 5 to the power of 3. This is the same thing as 1 all over 125. So this is the solution to this expression. Let us look at the next one. The next one, we have number 4. 4 to the power of 7 all over 4 to the power of 7. Applying the rule, this can be written as 4 to the power of 7 because we have division here. This can go up and we have minus 7. So this is same thing as 4 to the power of 0. 7 minus 7 is 0. And we all know that from the rule, anything raised to the power of 0 is 1. So this is the same thing as 1. So this is the answer to this expression. So the next one, number 5, we have a to the power of 3 times a to the power of 4 times a to the power of 5. So this can be written as a to the power of 3 times a to the power of 4 times a to the power of 5. I need to clear this parenthesis as because the parenthesis means multiplication sign if you see something like this. So in this case, applying the rule, this can be written as a to the power of 3 because it is multiplication. We need to add all of them. So 3 plus 4 plus 5. This is same thing as a to the power of 3 plus 4 is 7. 7 plus 5 is 12. So this is a to the power of 12. This is the answer to this expression. Number 4, we have 4x to the power of 2, y to the power of 5, all to the power of 3. So applying the rule, this is the all to the power of 3. So we can distribute to each of these. So this will become 4 to the power of 3 times x to the power of 2, all to the power of 3. Then we have times y to the power of 5, all to the power of 3. We just multiply this each power to this. So this is the same thing as having 4 to the power of 3 is the same thing as 64. So we have here x. This is 2 times 3, we have 6. And this is y. This is 5 times 3, we have 15. So this is the answer to this expression. So number 5, we have 5m to the power of 5 n times 4m to the power of 2 n to the power of 4. So what we are going to do is for us to collect all the constants and also collect all the variables. So this will give us, we have 5 times, we take 4. So we have times m to the power of 5. Then this side we have times m to the power of 2. We have the next one, which is n times, this is n to the power of 4. So in this case, we can see that 5 times 4 is 20. So we have 20. Then m to the power of 5 times m to the power of 2 is the same thing as m to the power of 5 plus 2. So we have the next one, n to the power of, this is 1. times n to the power of 4 is the same thing as to the power of 1 plus 4. So this will give us 20 m to the power of 7, then n to the power of 5. So this is what we have as a solution to this expression. So the next one, we are looking at number 8. So we have 36 x to the power of 3, y to the power of 9, all over 27 x to the power of 6, y to the power of 4. We can simplify this as 36 all over 27. So we have here x to the power of 3. Then here we have x to the power of 6. This will become minus 6. Then we have y to the power of 9. Then we have y to the power of 4 here. When this goes up, it becomes minus 4. Then here, we can use 9 to divide here. We have 4. 9 will divide here. We have 3. So this will give us 4 all over 3. So we have here x. 3 minus 6 is minus 3. And we have here y. Then we have 9 minus 4 is 5. So this is what we have. We can write this as, this can also be written as 4 all over 3 because we have x to the power of minus 3. So this x will come down. We'll have x here to the power of 3. Then here we have y to the power of 5. So we can write this as this. So either this or this, but I prefer this. This is more simplified than this. So the next one is 8b to the power of 3d multiplied by 4b d to the power of 2 all over 2 into 2bd all to the power of 2. So this can be written as, we have here 8 and we have here, when we multiply all the constants, 8 times 4, we have 32. So we have here b to the power of 3. Then we take this, we have plus 1. Then we have d to the power of 1. You take this plus 2. Then all over 2. 2 into, we have here 2. So we need to distribute the power to each of these. So this will be 2 to the power of 2, b to the power of 2, then d to the power of 2. So when we multiply out this is going to give us 4. So this numerator will give us 32 b to the power of 3 plus 1, which is 4. Then we have d to the power of 1 plus 2, which is 3, all over. This is something as 2 times 2 to the power of 2 is 4. 4 times 2 will give us 8. So this will become 8. We have b to the power of 2, then d to the power of 2. So in this case, for us to clear this, 8 can go here 1, and 8 can go here. We have 4. So here, this can be written as 4. We have here b to the power of 4. Here we have 2. So 2 goes up, become minus 2. We have here d to the power of 3. We have 2 here. 2 goes up, become minus 2. So this can be written as 4b to the power of 4 minus 2 is 2. Then we have here 3 minus 2 is 1. So 4d. So this is what we have, the solution of this expression. So the next one is number 10, where we have 12a to the power of 5, b to the power of 2, multiplied by 6 to the power of minus 1, a to the power of minus 2. So this can be written as 12a, taking the constant, we have 5 here. So 5 here, then we bring down this. Okay, we start with the constant first. So we have here 12 times minus 6. So we have 12 times 6 to the power of minus 1 will become times 1 all over 6. So we have here the variable, which is a. Our a to the power of 5. Taking this one, we multiply, we have minus 2. So we have the next one, which is b to the power of 2. Taking, we don't have here is 0. So this will become 6 will go here 1, and 6 will go here 2. So we are now left with 2 a to the power of 5 minus 2 will become a to the power of 3. Then we have b to the power of 2. So this is what we have as the answer to this expression. Let's look at the next one, which is degree of a term. The sum of the exponent on the variable in a term. So the degree of a polynomial is equal to the degree of the highest degree term in the polynomial. So let us look at example where we have this monomial where we have 3x to the power of 2y. So this, to determine the degree of this term in this monomial, is for us to add the power, since it says that it is the sum of the exponent of the variable. So the sum of the exponent is 2 plus 1. We have here 1. So 2 plus 1. So the total number of degree in this monomial is equals to, okay, this is 2 plus 1 is equals to 3. So this is the 3 degree 3 to this monomial. So now the next one, we have minus b to the power of 4 d plus b d to the power of 3 plus b to the power of 6. So the total the number of degree in this expression equals to, when we add 4 plus 1 is 5. This is 5. Then you have 1 plus 3. Here is 4. So here we have 6. So the highest number of degree is 6. So we have degree 6 in this expression. So for here, we have 7x y to the power of 5 z minus 15x to the power of 6. For us to add up to know the sum of the degree in this expression, we have, this is 1. When we add 1 plus 5 plus 1 will give us 7. That's 1 plus 5 plus 1 will give us 7. So in this area, we have x to the power of 6. So we have 6 here. So the highest degree in this expression is 7. So the next one is like terms. Like terms are terms that have the exact same variable with the exact same exponent. Example, where we have 3x to the power of 2y and 5x to the power of 2y. So here we have, even we have different constants, but what the variable says that have the same variable with the exact same exponent. So this variable have to the power of 2 here, and this x variable have the power of 2 here. And we have y here to the power of 1, and also y here to the power of 1. So this and this are like terms. So these ones are not like terms, where we have 3x to the power of 2y and 3x to the power of 2 and 3x to the power of 2 y to the power of 2. In this expression, this one we have x to the power of 2 here, and here y is to the power of 1. Here we have x to the power of 2, and y here is the power of 2. So this and this are not like terms. So let us see the example how we can collect like terms. So we have an expression like this: minus 2x plus 7y minus 5x minus 9y. So collecting like terms in this expression, here we minus 2x. This is the next one where we have minus 5x. Then we bring down 7y. Then we take this minus 9y. If you see that this and this, they are like them. So for us to further simplify this, when we subtract this one, minus 2x minus 5x will give us minus 7x. So here we have plus 7y minus 9y will give us minus 2y. So this is the solution of this expression. Look at this one. We have 7 plus 3x to the power of 2y plus 4y minus y plus 2x plus 8x to the power of 2y plus 8. For us to collect like them, let us look at the constant. We have constant here and we have constant here. So it's going to be 7 plus 80. Then we pick down this one plus 3x to the power of 2y. Then the next like term is this, because we have x to the power of 2 here, x to the power of 2 here. We have y to the power of 1 and y to the power of 1. So bring down this plus 8x to the power of 2y. So the next one is plus 4y. Then we have here, this is the same thing as 1y. Then we have minus y. So for us to evaluate this, 7 plus 80, we have 87. Then we have plus. When we add this, we are going to add the constant. 3 plus 8, we have 11. Then because they are like them, we take x to the power of 2y. Then we have 4y minus y will become 3y. So this is the answer to this expression. So the next one is distributive property. When we have expression like this, what we need to do is for us to multiply what we have outside the parentheses into each of the variables inside the parentheses. So we are going to multiply a times x, where we have ax and also multiply a times y, which we have a y. So these are the method that we are going to use for us to solve distributive properties in this polynomial. So here are the example. So we have 5 into 4x plus 2. Then for us to find the solution of this expression, we need to use a distributive properties for us to find here. So here we have 5 times 4x. So it's going to be 5 times 4x. Then we have plus 5 times 2. So this is what we have. So here 5 times 4x will give us 20x. Then we have plus 10. So this is what we have for us to have the solution of this. But we can further simplify this by dividing all through by 2 for us to have a simple answer to this. So when we divide all through by 2, we have 2 cancel here and 2 cancel here, 10. 2 cancel here and 2 cancel here, 5. So here will become 10x plus 5. So this is the simplified answer to this expression. So here we have minus 3 into 2x to the power of 2 minus 5x plus 4. So for us to find this, we have to distribute this, the product of minus 3 to each of these. So this will become minus 3 times 2x to the power of 2. We have minus 6x to the power of 2. So here is going to be minus 3 times minus 5x will give us plus 15x. So minus 3 times 4 will give us minus 12. So this is the simplified answer to this. But as well, we can also divide all through by 3 for us to have the simple answer to this. So this is, we do this, we divide by 3 and we divide by 3 and divide by 3. 3 will go here and 3 will go here too. 3 will go here and 3 will go here 5. 3 will go here and 3 will go here 4. So the answer to this will become minus 2x to the power of 2 plus 5x minus 4. So this is the simplified answer to this expression. So let's look at this. We have 3 into x plus 3 plus 2 into x plus 1. So what we are going to do is for us to expand this parenthesis. 3 times x will give us 3x plus 3 times 3 will give us 9. So we have here 2 times x will give us plus 2x. Then 2 times 1 will give us 2. So this is what we have. So here we can collect like terms as we said before. So this will give us, we collect 3x. 3x here. Then we have 2x. Then we have plus 9. Then we have plus 2. We have collected like terms. So here 3x plus 2x will give us 5x. Then 9 plus 2 will give us 11. So this is the simplified answer to this question. So the next one we have 4k into k minus 3 minus 2 into k to the power of 2 minus 3k plus 4 minus k to the power of 5 minus 5. So what we are going to do is first of all expand these parentheses through distributive properties method. So here 4k times k will give us 4k to the power of 2. 4k times minus 3 will give us minus 12k. Then we come here minus 2 times k to the power of 2 give us minus 2k to the power of 2. So we have minus 2 here times minus 3k will give us plus 6k. We have minus 2 times 4 will give us minus 8. Here we have minus, because we need to expand this, minus times k to the power of 5 will give us minus k to the power of 5. Then minus times minus 5 will give us plus 5. So we have this, we need to collect like terms. Collecting like terms, we take 4k to the power of 2. The next one is minus 2k to the power of 2. The next one is minus k to the power of 2. Then we bring down minus 12k. Then the next like term is 6k. We have plus 6k. Then we don't have another one, remain the constant, which is minus 8. Then the next one is plus 5. So here we can see that we have 4 minus 2 minus 1, because we are taking the coefficient of this variable. That is 4k to the power of 2 minus 2k to the power of 2 minus k to the power of 2 will give us k to the power of 2. 4 minus 2 is 2. 2 minus 1 is 1. So in case, instead of writing 1 here, we don't write 1 in the coefficient of this variable. So the next one is minus 12k plus 6k will give us minus 6k. So the next one is minus 5 minus 8 plus 5 will give us minus 3. So this is the simplified answer to this expression. So the next one is what we are going to look at, adding and subtracting polynomials. So here, for the example here, we have x minus 6 minus into 2 minus 5x plus into x plus 4. So we are going to see how we add and subtract this polynomial. So in this case, we have x minus 6. So it's going to be x minus 6. Here we are going to expand this with this negative sign. So it's going to be minus times 2 will become minus 2. Minus times minus 5x will become plus 5x. So when we open this parenthesis, we are going to have plus x plus 4. So collecting like terms, we are going to collect constant one side and also collect variable one side. So here will become, we take x plus, here we have 5x, then we have another x here, we have plus x, then we take minus 2, then here we have plus 4. So from here, we can see that we have x plus 5x is 6x. 6x plus x, we have 7x. So here will become 7x. Then we have minus 2 plus 4 will become plus 2. So this is what we have as the solution of this expression. So the next one we need to solve equation for us to see how we can deal with this variable to find the solution of each of the variable given in each equation. So here we have the first equation as x plus 4 equals to 7. For us to find the value of x, we need to make x the subject of this equation. So in this case, what we need to do is for us to subtract 4 from both sides. So this will become x plus 4 minus 4 equals to 7 minus 4. X plus 4 minus 4, this will cancel itself. So you now left with x equals to 7 minus 4 equals to 3. So the value of x equals to 3 in this equation. The next one is number 2. We will have g minus 5 equals to minus 3. For us to find the value of g from this equation, we have g, we need to add 5 to both sides, or we transpose minus 5 to this other side. So this will become, transposing minus 5 to this other side, this will become minus 3 plus 5, because minus 5 will turn to plus 5. So therefore, we have the value of g equals to, when we add minus 3 plus 5, will give us 2. So this is the value of g that we have. Number 3, 5u equals to minus 20. So what we are going to do is for us to divide by the coefficient of this variable for us to find the solution of this variable in this equation. So here we divide the both sides by 5. So this will become 5u divided by 5 equals to minus 20 divided by 5. 5 will cancel here and 5 will cancel here. 5 will cancel here and 5 will cancel here. 4. Therefore, u equals to minus 5. So this is the value of u that we have from this equation. Number 4 says 8 plus 7y equals to 15. So the first one, we need to collect like terms. So doing, we need to transpose 8 to the right hand side. So when we transpose that, we have 7y equals to 15. 8 will become minus 8. Therefore, we have 7y equals to 15 minus 8 will become 7. So for us to find the value of y, we need to divide both sides by 7. So we have here 7y divided by 7 equals to 7 divided by 7. 7 cancel here, 7 cancel here, 7 cancel here, and 7 cancel here. Therefore, we have y equals to 1. So this is the value of y that we have as the solution of this equation. So the next one, number 5, we have minus 8x minus 5 equals to 2x plus 15. First of all, in this equation, we need to collect like terms. So here will become we have minus 8x. So we need to transpose this into this other side. That will become minus 2x. Then equals to, we bring this, which is 15. Transposing minus 5 to this other side, it will become plus 5. So we have minus 8x minus 2x will give us minus 10x equals to 15 plus 5 will give us 20. So for us to find the value of x here, we need to divide both sides by minus 10. So we divide here by minus 10 and divide here by minus 10. This will cancel here and this will cancel here. This will cancel here and this will cancel here too. So we have minus here. So this will become x equals to minus 2. So this is the value of x in this equation. So the next one, number 6, where we have 4 into x plus 3 equals to 2 into x plus 2 minus 8. So the first step that we are going to do when we have an equation like this, we need to expand this parenthesis for us to see each of the section of the coefficient of the variable and constant. So here, 4 times x will give us 4x. 4 times 3 will give us plus 12 equals to 2 times x will give us 2x. 2 times 6 will give us plus 12. Then we bring down minus 8. Then here we need to connect like terms. Let's take 4x first. 4x, transposing this to this other side, become minus 2x equals to, we take 12 minus 8. Transposing 12 to this other side, become minus 12. You can see that automatically 12 here will cancel minus 12. We are now left with 4x minus 2x will give us 2x equals to, we have left with minus 8 this other side, so we become minus 8. So for us to find the value of x, we need to divide both sides by 2. So this will become divide by 2 and here divide by 2. 2 cancel here and 2 cancel here. 2 cancel here and 2 cancel here 4. Therefore, x will be equals to minus 4. So this is the value of x that we have from this equation. The next one, which is number 7, we have c all over 3 equals to 2. So what we are going to do is for us to find the value of c. So what this is the same thing as having c all over 3 equals to 2 all over 1. You see the same thing. We need to cross multiply. It's going to be c times 1, we have c. We have equals to 3 times 2, we have 6. Therefore, we have the value of c as 6. So in this case, number 8, we have 1 all over 4 into x minus 3 equals to minus 2. So first of all, in an equation, when we see a parenthesis, what we need to do is for us to clear parenthesis first before we look at the next step. So here, this will become 1 all over 4 times minus 3 will become minus 3 all over 4 equals to minus 2. So here, we need to subtract this fraction. By so doing, we need to find the LCM. The LCM of these two fractions is 4. So here, 4 divided by 4 is 1. 1 times 1x will give us x, still 1x. So 1 divided by 4 will give us 1. 1 times minus 3 will give us minus 3 equals to minus 2. So here, we can cross multiply the same thing what we did here. By cross multiplying, this is the same thing as minus 2 all over 1. So this will become x minus 3 times 1 is going to be x minus 3. Then we have minus 2 times 4. By cross multiplying will become minus 8. This will become minus 8. So here, for us to find the value of x here, we need to transpose minus 3 to this other side. So it becomes x equals to minus 8. When minus 3 transposes into this other side, it becomes plus 3. Therefore, the value of x equals to minus 8 plus 3 will become minus 5. So this is the solution of x, which is x equals to minus 5, satisfy this equation. So the next one, number 9, which is 1 all over 3 into x plus 4 equals to 1 all over 5 into x plus 2. So as I said before, when you have a parenthesis, you need to clear the parenthesis first. So this will become 1 all over 3 times x will give us 1 all over 3x. You can write it x all over 3. You see the same thing. Then 1 all over 3 times 4 will give us plus 4 all over 3. It can be 1 all over 3 times 4 is 4 all over 3 equals to the same thing. 1 all over 5 times x will give us x all over 5. Then 1 all over 5 times 2 will become plus 2 all over 5. So for us to play this, we need to add this fraction by having the LCM of this denominator. LCM of these 3 is 3. Then we have 3 divided by 3 is 1. 1 times x, we have x. Then we have 3 divided by 3 is 1. 1 times 4, we have plus 4. Equals to the same thing here. We have 5 as the LCM of the denominator. So we have here will be x plus 2. That's 5 divided by 5 will be 1. 1 times x will be x. 5 divided by 5 will be 1. 1 times 2 will be 2. So we have these two equations. So what we are going to do is for us to cross multiply. When we cross multiply, it will be 5 times the whole of here will be, let's do like this, 5 times x plus 4 equals to 3 times, or we have into x plus 2. So here we need to expand this parenthesis. 5 times x. Let's come to this other side. 5 times x, we have 5x. 5 times 4, we have plus 20 equals to, we have 3 times x, we have 3x. We have 3 times 2, we have plus 6. So doing, you can see that we need to collect like terms. So we have 5x. Bringing this to this other side become minus 3x equals to 6. Transposing 20 to this other side become minus 20. So in this case, 5x minus 3x will become 2x equals to 6 minus 20 equals to minus 14. So for us to find the value of x, we need to divide both sides by 2. This divide by 2, and here we divide by 2. 2 cancel here 1, and 2 cancel here 1. 2 cancel here, and 2 cancel here. We have 7. Therefore, the value of x equals to, we have minus 7. So this is the value of x that we have that satisfies this equation. So the next one, which is number 10, we have x minus 4 all over 5 equals to x minus 3 over 6. So what we're going to do, we don't have parentheses here. What we are going to do is for us to cross multiply. So we are going to cross multiply. It's going to be 5 times the whole of here will be 5 into x minus 3 equals to 6 into x minus 4. So we have to open the parentheses. 5 times x will have 5x. 5 times minus 3 we have minus 15 equals to 6 times x, we have 6x. 6 times minus 4, we have minus 24. So in this case, we have to collect like terms. 5x here first. We take transpose 6x to this other side, become minus 6x equals to minus 24. Transposing minus 15 to this other side become plus 15. So here, 5x minus 6x will come minus x equals to minus 24 plus 15. This is going to give us minus 9. So here, minus can cancel themselves. Therefore, x equals to 9. So this is the value of x that satisfies this equation. So the next one that we are going to have is number 11, where we have 12 into x plus 1 all over 2 plus 2x plus 3 all over 3 equals to x all over 4 times 12. So what we are going to do is for us to expand this first. So this will become 12 times or into x plus 1 all over 2 plus 12 into 2x plus 3 all over 3 equals to, this is going to be equals to 12x all over 4. So what we have here, 2 can cancel here, 2 can cancel here 1, and 2 can cancel here 6. 3 can cancel here 1, 3 can cancel here 4. 4 can cancel here, and 4 can cancel 3. So we are now left with 6 into x plus 1 plus 4 into 2x plus 3 equals to 3x. So we need to expand this parenthesis. So this will give us 6 times x, we have 6x plus 6 times 1, we have 6, plus 4 times 2x, we have 8x. 4 times 3, we have plus 12, equals to 3x. So we need to collect like terms. So this will become, we take 6x first, then we have plus 8x. Transposing 3x to this other side, it becomes minus 3x, equals to, we need to transpose 12 to this other side, become minus 12. Transpose 6 to this other side, become minus 6. Therefore, the value of x from that equation is going to give us, let's say we have 6x plus 8x minus 3x equals to minus 12 minus 6. So 6x plus 8x minus 3x. Okay, let's take this first. We have 6x plus 8x minus 3x will become 5x, equals to minus 12 minus 6 is going to give us minus 18. This is the same thing as 6x plus 5x is going to give us 11x, equals to minus 18. So what we're going to do for us to find the value of x is for us to divide both sides by 11. So this will become divide by 11, and here divide by 11. So in that case, what we are going to have as the value of x, 11 will cancel here, 11 will cancel here. Therefore, x equals to minus 18 all over 11. So this is the value of x that satisfies this equation. So that is what we have for this section. So we are going to continue in part 2 for us to see how we are going to deal with grade 9 mathematics. Follow us on our Facebook page, subscribe to our YouTube channel, comments, and share our video for more interesting topics. Thank you.